balance and advancement.
A NASA program recently released an article, the link is right here if you want to read it. In the article, they said that they are thinking about building a robo-sub and a robo-drone to launch onto Titan to explore. But the robo-sub can only stay on the water and explore, and the robo-drone can only stay on the land. So we came up with the idea of the hovercraft because it can go on both the water and the land to explore. So some of the basic features of our hovercraft is that it is controlled by two Arduinos, one Arduino Mega, one Arduino Uno. It has 4 motors, 2 steering motors, one lift motor, and one thrust motor. And in the front here, there are 2 ultrasonic sensors which help the craft avoid collisions.
And the hovercraft features are posted on the wall over there. So as Eric said, there's a Arduino Mega, there's a bunch of sensors connected to it. So basically what it does, it takes all the readings from the sensors, puts it in a packet-like structure, sends the whole packet to our destination and it'll display the data using processing. So Eric has the remote. Once he presses a button, he'll send a Bluetooth message over to this NXT over here. And then that's the control sensor. And then it'll send an XB message, which is in there, you can't see it, and it'll send it over to the hovercraft and it'll do whatever it tells it to do. And the communication system flow chart is over there.
So then the data sent from the hovercraft is sent to this X-ray over here, and it goes through the Arduino board, and it goes into the computer. The computer decodes all the voltage sensors, and it displays it on the screen. So for instance, it can display the temperature in Celsius, the humidity percentage, roll, pitch in degrees of the hovercraft, and the hovercraft's lift bands, thrust bands, current, voltage, and power.
So now if we want our hovercraft to lift and explore, all we have to do is send a Bluetooth message from this controller to that controller, which will send an NXTB message to the XB on the hovercraft, which will tell it to lift.
So when the lift fan turns on, the power will increase and the voltage and current will increase. So what Brian is doing right now is he is shifting the hovercraft so he can affect the pitch and roll in this box. And he's using a hot air dryer. And since hot air is very dry, this increases the temperature and this lowers the humidity.
So now if we want the hovercraft to move forward, we send a different Bluetooth message to the hovercraft here to tell the hovercraft to start moving and exploring. The hovercraft uses ultrasonic sensors to avoid obstacles in its way.
Turning on the thrust fan, and since the ultrasonics affects the thrust fan, the thrust fan power goes up and the voltage goes down, but the current also goes up.
Our hovercraft can autonomously explore Titan because it uses its ultrasonic sensors together with the steering fan so that it can steer clear of anything that might be hurtful to the
So thanks for listening to our hovercraft system. If you want to know more about this project, we have a bunch of information along these walls, and there's a big board. There's a video. It's really awesome. Thanks for watching. Any questions?
This is a method of getting clean, renewable energy from the sun in space and bringing it back to the Earth.
SSP is going to solve 2 of humanity's greatest problems, those being the energy crisis and increasing greenhouse gas emissions.
The SSP can collect large quantities of energy from the sun and wirelessly transfer the energy back to the Earth.
This is our Lego and Tetris platform that we use to model the SSP. If you look here, this is a Tetris motor that will rotate the Earth. This is our SSP module, and this is our saw.
Our SSP module contains many different components to make it function properly. First, we have solar panels which will harness the sun's energy. We also have robotic arms that will expand the solar panels when they are in space to reduce launch costs. Now we have a on-deck motor system that is going to use solar energy to process any functions that it needs on deck. And lastly, we have a wireless energy transfer simulator.
You guys are probably wondering what this is right here. This is our data log, and it shows each different value. As you can see here, the green line is running across the screen is our voltage, the red line is our current, and the blue line is our wattage. We have a black line running across the screen right here, and that's our gyro sensor. That tells us what direction our solar panels are moving. And on top, we have a brown line here, that's our light sensor, and that tells us how intense the sun is lighting. These are the readings of the solar panel when it's on Earth and when it's daylight. Now we will show you our readings when it's at night. Notice how the voltage, the current, and the wattage all went down to around flat or zero. This is because at night there's no sunlight, so our solar panel can't collect solar energy.
So now we will launch our SSP into space. So now you can see that it is making a low Earth orbit. This is to reduce costs and to make transportation of the materials easier. Now it is moving up to geosynchronous orbit, 22,000 miles above the Earth. Here it will be fully constructed through the use of robotic arms.
If you look closely, the solar panel is trying to align itself with the sun, so it can always be facing it. This is something we like to call control mode 1, and this is used to maximize the gathered energy.
So now we'll show you something called control mode 2, also known as optimization. Our SSP will rotate back and forth to try and find the brightest source of light so that it can point directly at it and maximize its energy intake. You see that it ends up pointing directly at the sun, but we can do this from any direction. This means that we can always point directly at the sun from any point in the Earth's orbit. You can see that we always point at the sun.
I'm now going to explain our wireless energy transfer simulator. So using the electromagnetic principle of induction, we have created two circuits that are going to wirelessly transfer energy through space.
In reality, on a real SSP that we were to launch into space, we would be using microwaves or laser beams to wirelessly power transfer energy back to Earth.
Space solar power, or SSP, is the next big advance for mankind. This is on the level of the development of fire and the internal combustion engine. This is not just going to help our energy problems, and it's not just going to be a step in the right direction. It will completely solve all of our energy needs. Thank you for listening to our presentation.